We are going to be starting a new session today in the topic of machine translation. I'm sure you would have noticed that we have been progressing from the understanding of the corpus and then finding out the frequency of words, and then we try to find out what the meaning of embedding, try to understand the context of the words, and then try to get the neighborhood words in terms of the word embedding, and then later we try to formulate newer machines or newer machines in terms of neural networks to really do the same job. And then later we try to address from the words to the sequences using recurrent neural networks. I'm sure you'll be noticing that progression, right? From the words to the word embedding to the sequence of words and so on. So, what is the next stage? The next stage in this understanding is to really understand a sequence of one language and then translate it into another language. We have been considering only the language English for our purpose so far. Any language that is very similar to the English structure can also be used in the scenario that we had discussed. Okay. Now, what we want to do is we want to find out if the mechanism that we have understood, the technologies that we have understood, the fundamental that we have seen so far, could it be used for machine translation. So, this is going to be an interesting topic that we want to take up today. So, what is the important things that we have seen so far, right? So, trying to understand the meaning of the word without even looking at the dictionary, trying to generate sentences and then try to figure out the probability of a sentence formed using the machine or the neural networks or using some probability models, right. So, now we are going to take it to the next level in terms of identifying a new model where we can feed in a text in one language and we want to get the translated version through that model. So, that is going to be a very interesting task and a very challenging task, and this is not very new. People have been trying to do the machine translation for over 50 plus years. When they started the machine translation, the power of the machines were too small. Even some of the digital watches that we have today, they are more powerful than the computers that they had earlier. So, that means more and more processing can be done, and then more and more corpus can be processed, parallel corpora can be constructed and processed, and automatic ways of extracting words and translations are going to be a reality very soon. Even though we have seen that these techniques that we had seen so far have not been successful to the level of 100%. There are some elements of error here and there, and we are still improving those. I am sure in about 20 plus years we will have a very good models that would be able to do all the job with 100% confidence and so on, right. Okay. So, in order to understand how people have been doing machine translation over the last 50 plus years, we will first look at the basic element that they had looked at and how they have progressed, and then later we look at some statistical models or statistical machine translation aspect, and later we will try to apply a neural model into it and see how we can successfully translate a sentence in one language to the other language. All right. Okay. So, let me take you through the content that I am going to be talking about today. So, some of the element that I am going to be talking about is on the statistical machine translation part. Okay. So, we will first look at various approaches followed by people to machine translation, and then we will look at how we can automatically translate one sentence to the other. And then later we look at some parallel corpora, what is really required for us to do the statistical machine translation. Okay. So, what do you mean by parallel corpora? And then we try to apply the model into a noisy channel model. Those of you who have studied the information theory would know this very well. We look at the Bayes rule, which is very fundamental to the machine translation. And then we will just have some recap on the language model, because it is very important for you to know the sentence that you have created really is something that we can use, using some probability models. And then we will see what actually is a translation model. We will also look at something called as alignments. And then in the later part of the lecture, we will look at the neural models for doing all these. Okay. All right. So, this is something that you should be aware of. Okay. So, this person Warren Weaver in 1947 mentioned that I think at the beginning of the Cold War, he said when he looks at an article in Russian, this is really written in English, but it has been coded in some strange symbols. I will now proceed to decode. So, this is how he looked at the translation from Russian to English. Okay. So, what he says is the text that is really written or that you see as Russian is written in English. When it comes through some channels, right, it becomes a Russian, and then I want to estimate what was originally written, and that is what he wants to decode. So, that is what he said, and then after this flurry of activities started in the natural language processing aspects of machine translation. Okay. So, this diagram called Vacqua diagram discusses various approaches to machine translation in one shot. Okay. Rather, it gives you the various approaches people have followed to machine translation in one simple diagram. If you look at this diagram, on the left side you see the source language, on the right side you get the target language, right. So, how do we really take the source language and then translate it to the target language? So, one way to look at it is we have a sentence, let us say in English, and I want that to be translated into French or vice versa, right. So, we call the source language, let us say, as French, and then the target language as English. So, in this case we are going to be translating from French to English, right. So, what are the ways that we can do it? So, if you do not know the language, the target language, what do? You get the dictionary, the English or French to English dictionary, look at the source language sentence, take one word at a time, and then find out what is the actual meaning of that in English, and then write that word, and then take the next word and then write the next word in the target language, and so on, right. So, once you converted all the source language words into the target language, you have a bag of words. Okay. I am using the term bag of words because the structure of the language on the left side could be very different from the structure of the language on the right side. So, once you have translated or rather converted all the source language words into target language word, what you do is you just rearrange them so that it makes sense. Okay. So, how do you know that you have really translated the real meaning of the source language into this? It is not possible to really know if you do not know the source language. So, you need to go to somebody who understands both language and then ask them whether the translated version is right or wrong. Let us assume that he is the person who has the gold standard, who understands both languages and translates from source to target very well. So, you take the sentence to him, and then that person validates, saying that no, this word is not to be translated in this fashion. it is different. For example, if I use so in case of English, if you have the word bank, okay, if it appeared. So, for the sake of understanding this, I am just assuming that we are going to be doing the translation from English to French. The bank, we have seen earlier that it means different things based on the context, right. So, this is a polysemy, right. The same word meaning different things. It could be the river bank, or it could be the financial institution, or it could be a verb, I bank on you, or to do certain things. Okay. So, how do you really translate bank into the respective word in French? Okay. So, there could be different words associated with the polysemy of English. So, we should know the context, and then based on the context we can probably say, I am just making it up, it could be BANK, which will mean the river bank, or pardon me, I do not know French, I am just making it up. Okay. This could be the financial institution, this could be the river bank. So, the person who understands the language would really translate the word, and then based on the context he will use the appropriate word in the translated sentence. Okay. So, is it really possible to convert all the languages in this fashion, word by word, without knowing the syntax structure? It is not possible, right. So, that is why we go to the person who we assume as a person holding the gold standard of translation. Okay. So, it is almost impossible for you to do the translation without understanding the syntactic structure of both languages. Okay. So, what is the next level? What people have done next level is they have taken to the syntactic structure level. For example, you can construct a syntax tree. Okay. So, you can construct something like this. A sentence could be your noun phrase, a verb phrase, and then you can still do all this, right. So, if I am able to construct my sentence in this fashion, and then assuming that the language that I am going to be translating the source into the target also has a similar structure. If I have a similar structure, then I can take each one of those that are in the slots or nodes into the respective node on the right side. So, here like this. Suppose if this target language also has the same structure, so I can take it like this. Okay. So, is there a difficulty with this? I think there are some difficulties with this, because sometimes the words are swapped, before or after, depending on the language. Every language is very different in their own way. So, we cannot expect that to be very similar to what we have seen with English. Okay. So, what you do is you construct a very similar structure, syntax structure or the tree, which need not be same as what we have constructed for the source language, and then try to map that in. Still there would be a problem, because we do not understand the semantics of that, right. So, what you do, you instead of doing this, you go into the semantic world, try to understand the meaning of the sentence, and then based on the meaning of the sentence, do the translation. For this, again you require a good understanding of both languages, correct. And then if you want to do any of this, right. So, whatever we have listed in 1, 2 and 3, we can only do translation from one language to the other. So, there are difficulties. People have been attempting this and they have not been very successful in 1, 2 or 3 so far. So, it is it's a very difficult task, it's a very intellectual task, you know well, right. And then what they also attempted was try to create a interlingua. Interlingua is something that represents the knowledge of the language. Okay, right. It's a very a neutral model where you can represent a language, and when you get a source language, you can translate that into that interlingua model. If I create this interlingua, I can say translate to interlingua to French, to German, to Spanish, to Hindi, Tamil or whatever. Okay. So, creating the interlingua is a very critical aspect. So, is it really possible to do that? I think a lot of interesting examples are available in the internet, in the scientific research community. You may want to look at that and see how they really create the interlingua. It is very similar to what we have done with XML or JSON, right. Now you would know. So, it is earlier we used to have our own way of passing the packets from one application to the other. So, instead now what we do is we use an XML mechanism or a JSON mechanism to read the XML or decode the write the XML or decode the XML. In the same fashion JSON also can be used, right. So, in the same fashion we create something here very similar to this model, and then try to use various translators to make use of the interlingua to translate it into their own language. So, this is a very ideal model, correct. People have not been very successful in doing that so far. Okay. All right. So, as I mentioned earlier, the word to word or the literal translation is done by taking every word from the source and then convert that into the target language, and take one word at a time and try to construct the sentence in the target language without really understanding the context. This is more of a dependency graph rather than a syntax tree. It is a little more advanced, where you can also find out how these parts of speech are connected. Okay. So, for example, the determiner, here I have the bus leaves at 10 a.m. So, I have actually used a Google API to do this. I gave the sentence to the Google API and then it gave me this graph. Okay. So, the sentence I used was the bus leaves at 10 a.m. So, you can see that it is able to really create the parts of speech, right. So, in the syntactic translation, what you do is you have another dependency graph created for the other language in this similar fashion, and then move the words into the respective slots. Okay. So, like I have shown here, you move the subjects source of the subject of the target, subject of the target, and then noun from the source to the node where noun is represented in the other graph, and so on. So, we can generate a sentence without really understanding what that sentence is talking about. Again, the context is not considered, but this is somewhat better than the first model where we did the literal translation using words. The third one, as I mentioned, it is about understanding the meaning of the sentence, and then using the semantics you construct the target language. The next one is, as again we discussed about that, considering an interlingua as an intermediary, which we can use it to translate, and then from here we can translate it to multiple languages. The idea of this is to have multiple system using the same knowledge base, right. So, if you are able to construct the interlingua from the source language, now it is possible for us to really generate the target sentence in any language. So, instead of having several translators, we just have one model where we create the intermediary knowledge from the source language, and then using that knowledge construct the sentence for the other languages. So, this is another mechanism. By doing that, we are also reducing the complexity in this fashion, right. So, as I mentioned, it is very difficult to design. So, this is what have been attempted by people earlier.